Walk the floor of any modern industrial facility, and you will see an environment defined by continuous motion. A refinery or a manufacturing plant survives on uptime, operating at a scale where execution and timing are everything. Behind that physical execution lies a digital paradox. An organization's computerized maintenance management system can operate flawlessly from an IT perspective, servers online, software patched, while remaining useless to the maintenance teams actually doing the work. This graphic details the symptoms of that misalignment. Systems with untrusted data generate broken workflows and polished reports that answer no real questions. Frontline workers abandon the clunky software, building offline shadow spreadsheets just to get through the day. If leadership constantly has to ask for the real numbers outside of the official database, the organization has a trust problem. System failure in an industrial setting is rarely a software defect. It is an architectural misalignment, built by treating software deployment as an IT checklist rather than a reflection of field reality. This visual represents the chasm. Maintenance operations sits on one side, trying to keep assets running, while IT infrastructure sits on the other, managing data storage. Between them is a massive operational void. Maintenance Information Management, or MIM, provides discipline bridging that void. It ensures the right information is captured, controlled, and used to improve physical decisions. Effective MIM leads to predictable compliance and reliable asset history. Without it, teams waste hours reconciling conflicting numbers and duplicating effort across separate silos. Fixing this divide requires abandoning the internal vendor-client dynamic. Maintenance must move past submitting a ticket and waiting for IT to deliver a finished product. A maintenance platform serves as a continuously co-designed enterprise asset, requiring input from both sides throughout its lifecycle. To co-design that asset, we establish strict boundaries mapping exact ownership. On the left, maintenance owns the process, controlling decision logic and the meaning of data. On the right, IT owns the infrastructure, managing the secure servers and integrations that protect that information. Consider what happens when these boundaries are violated. A centrifugal pump suffers repeat failures, yet engineers find the maintenance data entirely blank. While the software runs perfectly, the workflow logic contains a mechanical flaw. IT configured the system to demand that technicians close out their work orders before the prompt for failure mode data appears. Because this digital sequence contradicts physical reality, technicians skip the final data entry. The history vanishes, and reliability engineering is blind. Digital workflows must perfectly mirror physical execution sequences. If they don't, frontline workers will bypass them, rendering the data useless. High-value systems require a pre-configuration blueprint. You have to lay the foundation before you build. Before IT configures a single field, maintenance must deliver 3 prerequisites: clear decision rights, end-to-end data flows, and strict evidence for regulatory compliance. A conveyor gearbox at a mining site provides a clear warning. Leadership spent thousands developing a performance dashboard that everyone actively ignores. This dashboard fails because it presents over 40 key performance indicators without tying a single one to a specific operational decision or trigger. Routine monitoring requires high-signal metrics for daily direction. In contrast, investigating a gearbox failure is an ad hoc process. Mixing these two distinct needs destroys the utility of both. It comes down to this core rule. The real risk isn't failing to measure. It's measuring everything and managing nothing. Dashboards possess value only when they act as direct triggers for operational decisions. Otherwise, they are just digital decorations. In a municipal fleet operation, strict enterprise cybersecurity mandates are actively sabotaging maintenance data quality. To protect the network, IT required multi-factor authentication for every minor mobile action or any routine record update happening on the floor. Rather than authenticating 20 times a day with greasy hands, technicians delay their data entry until the end of the shift. They rely on paper notes, error rates skyrocket, and the organization loses real-time visibility. Workflow-aware security provides the solution. High-risk actions like changing master asset data route through the heavy digital padlock. Routine field updates flow through an unobstructed pipeline to ensure accuracy and speed. When security controls ignore operational reality, employees invent workarounds, destroying the exact data the policy was meant to protect. Modern industrial operations must correct a major industry misconception. A single source of truth functions by establishing one authoritative owner for each specific dataset, allowing for automated, controlled synchronization across platforms. This graphic shows the flow. Information moves automatically from the work order to the costs, into asset history, and finally to the dashboard. But integration carries risk. Without governance, point-to-point links automate bad data at scale. Before coding, teams must identify the specific problem, the official record owner, and the fallback plan for when the API breaks. Integration is a powerful tool, but without maintenance leading data governance, it simply duplicates errors faster. Maintenance information management operates as an ongoing capability. It requires a monthly governance rhythm to prevent decay and ensure the system evolves with the business. Successful alignment builds this structure. Data flows accurately and bidirectionally across a co-designed bridge, supporting both infrastructure security and field operations. This is the final requirement for world-class operation. The organization moves from IT gave us a system to maintenance and IT designed a solution together. A technically flawless system means nothing unless it empowers better physical action. Real operational return on investment begins the moment maintenance and IT stop acting as separate vendors and start acting as strategic partners.